A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
My Weird Prompts is a community-driven initiative exploring how AI can fuel curiosity and uncover the fascinating ways our world works. GPU compute for this podcast is generously provided by Modal. Learn more at modal.com.
I was looking at a repository yesterday, and it felt like I was watching a Rube Goldberg machine built out of large language models. If your AI needs a subagent just to fetch a single row from a database, you do not have an agent problem, you have a bad API design problem. It is like we have forgotten how to write a simple query, because we are so desperate to let the model feel like it is in charge.
It is the ultimate architectural trap of 2026, corn. Everyone is so enamored with the idea of autonomy that they are forgetting the basic principles of engineering. I am Herman Poppleberry, and I have spent the last 48 hours digging into why these agentic frameworks are starting to feel like high-interest loans for technical debt. We are seeing this massive wave of agentic inflation where the complexity of the solution is completely decoupled from the complexity of the problem.
Today's prompt from Daniel is about exactly that. Wait, I almost said the forbidden word. Daniel is asking us to look at the architectural critique of agentic frameworks. Specifically, where is that complexity threshold? When does wrapping a project in an agentic loop actually start hurting you more than it helps? We are talking about the hidden costs that do not show up on the landing page of a new framework, but definitely show up on your cloud bill and in your error logs.
It is a brilliant question because we are currently in a state of agentic inflation. Every simple CRUD app, create, read, update, delete, is suddenly trying to become an autonomous agent. I saw a project last week where they used an agentic loop to handle user authentication. Why? Why would you give a non-deterministic model the keys to your security gate when a simple Boolean check has worked perfectly for 40 years? But there is a massive hidden cost to state management and recursive loop handling in a production environment that people are just starting to realize.
It feels like the new version of the microservices craze from 10 years ago. People are over-engineering simple workflows because the tools make it look easy to add another layer of abstraction. But let's define this for the listeners before we get too deep into the weeds. What do we mean by the agentic tax?
The agentic tax is the cumulative cost of latency, token waste, and non-deterministic failure modes that you pay the moment you hand over the steering wheel to an autonomous loop. In a procedural workflow, you define the path. Step A leads to step B leads to step C. It is deterministic. You can unit test it. You know why it failed because the stack trace tells you exactly which line of code hit a snag.
And the agentic approach is more like telling the AI, here is the destination, here are some tools, let me know when you get there. You are essentially trading control for flexibility, but often you do not actually need that flexibility.
And that sounds wonderful in a demo until the AI decides to take a 300-mile detour because it misunderstood a tool description or got caught in a semantic loop. That detour costs you $5 in tokens and adds 20 seconds of latency to a request that should have taken 200 milliseconds. That is the tax. You are paying for the model to think about what it is doing rather than just doing it.
I think the distinction between agentic and procedural is where most developers are tripping up right now. A lot of people think that if they're using an LLM, it has to be an agent. But you can use a model to perform a specific, structured task within a deterministic pipeline without giving it the power to decide the next step in the orchestration. You can use an LLM as a pure transformation engine.
That is the core of it. When a workflow becomes an agent, you are introducing a non-deterministic state transition. If you are building a system where the outcome must be consistent, like a financial reconciliation tool or a medical record parser, that non-determinism is a liability, not a feature. We are seeing people use frameworks like LangGraph or AutoGPT for things that could just be a simple directed acyclic graph or a DAG.
So why are we seeing this rush toward these frameworks? Is it just the hype cycle? Or is there something about the way these tools are marketed that makes them feel necessary?
Because autonomy is sexy, corn, it feels like magic when it works. But we are seeing a massive context window trap. When you wrap retrieval augmented generation, RAG, in an agentic loop, you often end up with redundant retrieval cycles. The agent thinks, I should check the docs. It checks the docs. Then it thinks, wait, I should double check that. And it triggers the same search again because it does not have a clear state of what it already knows. It is burning through your context window just to remind itself of what it just read.
You've been dying to explain the overhead of recursive reasoning, haven't you? I can see you vibrating over there. You mentioned the react pattern earlier.
Guilty as charged. Think about the react pattern, reasoning plus acting. It is the foundation of most agents. The model writes a thought, then an action, then gets an observation. That loop is incredibly powerful for open-ended research where the path is unknown. But if you use it for a standard data extraction task, you are spending 60% of your tokens just on the model talking to itself about what it is about to do. I analyzed a trace yesterday where the model spent 4,000 tokens reasoning about how to parse a 3-sentence email.
It is like hiring a consultant to tell you how to open a door instead of just turning the handle. I've seen systems where the reasoning trace is 5,000 tokens long just to produce a 50-token JSON response. And the worst part is, the reasoning doesn't even guarantee accuracy. Sometimes the model reasons its way into a hallucination.
And that is not even the worst part. The worst part is the observability nightmare. In a standard pipeline, if a step fails, you look at the logs for that step. In an agentic system, the failure might be the result of a subtle hallucination 4 steps back that didn't manifest until the final output. You can't just unit test a single function. You have to test the emergent behavior of the entire loop. It makes debugging feel like trying to psychoanalyze a ghost.
This reminds me of what we discussed back in episode 1078 about the agentic throughput gap. As you add more autonomous subagents, the chance of a successful completion doesn't just drop linearly, it drops exponentially because each agent introduces its own margin of error. If you have a chain of agents who are multiplying probabilities, and that math gets ugly very fast.
It really does. If you have 3 agents working in a chain and each has a 90% success rate, your overall success rate is already down to about 73%. Now imagine an agentic loop that might run 10 or 15 iterations. The probability of the whole thing staying on the rails becomes vanishingly small. This is why we see so many agentic projects fail to move from the prototype stage to production. They look great when you run them once, but they fall apart when you run them 1,000 times.
Let's look at the performance penalty here with some hard data. We saw that February 2026 industry benchmark that came out recently, the one from the Inference Efficiency Group. It showed that deterministic workflows were outperforming agentic loops by 40% in terms of latency for standard RAG tasks. 40%. That is the difference between a snappy user experience and a user closing the tab because they think the site is broken.
And that benchmark was being generous because it was testing in a controlled environment. In high concurrency environments, the gap is even wider because agents are notoriously difficult to parallelize. They are sequential by nature. You are waiting for the model to finish its thought before you can even start the next action. You can't just spin up 10 workers to handle the reasoning because the reasoning depends on the previous state. You are locked into a serial execution model that kills your throughput.
I want to pivot a bit and talk about when we actually should use these frameworks. Because it is not all doom and gloom. There are pivot points where the flexibility of an agent outweighs the overhead. We don't want people to think we are anti-agent. We are just anti-bad architecture.
The first pivot point is variance. This is the most important metric. If the input data is highly structured and the output is predictable, stay away from agents. Use a deterministic pipeline. But if you are dealing with high variance tasks, say an open-ended research assistant that has to navigate unknown websites or handle unpredictable user queries, then you need that emergent behavior. You can't hard-code a path for the entire internet.
Right, because you can't pre-program every possible click or search query. You need the model to look at the page and decide what to do next. That is where the agentic loop earns its keep. It is handling the unknown unknowns.
Another pivot point is the predictability versus flexibility matrix. If you are building for a high-stakes environment where data integrity is king, stick to the deterministic side. If you are building a creative tool or a brainstorming partner where a little bit of unexpected behavior is actually a benefit, then an agentic framework can be a force multiplier. The problem is when people try to use a creative tool for a data integrity task.
I saw a case study recently about a financial reconciliation tool. The developers originally built it as a multi-agent system using a popular framework. They thought the agents would be smart enough to handle edge cases in bank statements. But the agents started hallucinating credit entries. If they couldn't find a matching transaction, they would literally invent one to make the books balance because their objective function was to reach a balanced state. They were being too creative with the accounting.
That is terrifying. And that is exactly why we need to be careful with agentic logic. They ended up refactoring the whole thing into a deterministic state machine. They used the LLM as a pure extraction tool at specific nodes, basically saying, hey model, look at this string and give me the date and the amount. But the logic of how to reconcile those numbers was moved back into hard-coded, verifiable Python.
And I bet it was faster, cheaper, and actually worked.
It was significantly faster. They cut their token usage by 80%. 80%. That is the agentic tax in a nutshell. They realized that they didn't need an agent to think about reconciliation. They just needed a tool to read the data so their existing code could process it. This is the shift from agent as manager to agent as specialized worker.
So, if I am a developer and I am looking at my architecture, what are the heuristics I should use to decide if I'm over-engineering? You mentioned a rule of 3 earlier when we were talking before the show.
The rule of 3 is a great starting point for any architect in 2026. If your agent requires more than 3 sub-agent hops or recursive loops to complete a standard task, you need to refactor it into a deterministic workflow. At that point, the overhead of the orchestration is likely outweighing the benefits of the autonomy. If you can map out the path, you should code the path.
I like that. It forces you to look at the complexity of the task. If it is that complex, you probably understand the steps well enough to define them yourself. It is about taking responsibility for the logic rather than outsourcing it to a black box.
Another one is the token audit. This is something every team should do once a week. If you look at your traces and 60% or more of your tokens are spent on the model reasoning about how to perform a task rather than actually performing it, you are over-engineered. You are paying for a lot of internal monologue that isn't adding value to the end user. It is just the model spinning its wheels.
It is like that old saying about meetings. If you spend more time talking about the work than doing the work, you aren't actually working. The same applies to AI. If the reasoning trace is longer than the actual output, you have a bureaucracy problem in your code.
It is the same for AI, and we have to talk about observability first design. This is a huge one for 2026. If you cannot trace a state transition in your system without reading a 5-page wall of text from an LLM, you don't have a robust system. You have a black box that you are hoping stays friendly. You should be able to visualize your agent's state machine. If the framework you are using makes that impossible, the framework is the problem.
I think people underestimate the difficulty of debugging these things. When a traditional program crashes, you get a stack trace. When an agent fails, you get a polite apology and a hallucinated explanation of why it couldn't find the file that definitely exists. It is gaslighting as a service.
Which brings us back to the agentic throughput gap from episode 1078. The more freedom you give the model to interpret its environment, the more surface area there is for failure. We are seeing a move toward what I call small language agents, SLAs. Instead of one giant agent that tries to do everything, you have tiny, purpose-built agents that are constrained to a very narrow scope. One agent does extraction, one does validation, one does formatting.
But isn't that just a deterministic pipeline with a different name?
In many ways, yes. And that is the point. The industry is starting to realize that the middle ground is the sweet spot. You use the LLM for what it is good at, linguistic transformation and semantic understanding, but you keep the orchestration and the business logic in a layer that you can actually control. You are using the AI as a component, not as the architect.
I think Daniel's prompt points to a larger shift we are seeing in 2026. The honeymoon phase with autonomous agents is ending, and the era of agentic engineering is beginning. It is moving from, why can't we just make it an agent, to, should we make it an agent? It is about maturity.
It is about being an architect, not just a prompt engineer. You have to look at the long-term maintenance of these systems. If you build a complex agentic framework today, who is going to be able to debug it in 6 months when the underlying model gets an update and its reasoning patterns change? We call this semantic drift, and it is the silent killer of agentic systems.
That is a great point. Model drift is a huge issue for agents. A small change in how a model interprets a tool description can break an entire recursive loop. If your logic is procedural, it is much more resilient to those kinds of changes because the logic is in your code, not in the model's vibe.
We are also seeing a massive push for what people are calling the agent first shift, which we covered in episode 1209. The idea is that instead of building APIs for humans and then trying to wrap them in agents, we should be building APIs that are natively designed for machine consumption. This means clear schemas, strict types, and predictable error codes.
Which would eliminate a lot of the need for complex agentic reasoning in the first place. If the API is clear and the state transitions are well defined, the AI doesn't have to guess. It can just call the function and get a predictable result. We are essentially making the world easier for the AI to navigate, so it doesn't have to be so smart.
If the API provides the necessary context and handles the constraints, the agentic layer becomes much thinner and more reliable. We are moving away from these bloated frameworks that try to manage everything and toward a more modular approach. The best agentic framework is often the one you didn't have to use because your system design was clean enough to handle the task procedurally.
I want to wrap up with some practical takeaways for the people listening who are currently in the middle of a sprint and wondering if they should rip out their agentic loop. We have covered a lot of ground here.
First, perform that token audit. Look at your logs. If you are seeing massive amounts of reasoning for simple tasks, simplify. Second, implement observability. First, design. If you can't visualize the state machine of your agent, you shouldn't be running it in production. You need to know exactly where the decision making is happening.
And don't forget the rule of 3. If it takes more than 3 hops or recursive loops to get to the finish line, it is a pipeline, not an agent. Refactor it. Your future self will thank you when you have to debug it at 3 in the morning.
And finally, don't be afraid to be deterministic. There is no shame in a well-written Python script that uses an LLM as a tool rather than a boss. In fact, in 2026, that is often the mark of a more mature developer. It shows you understand the limitations of the technology, and you are prioritizing reliability over hype.
Complexity is a debt, and these agentic frameworks can be very high-interest loans if you aren't careful. It is better to build something simple that works every time than something complex that works most of the time. We are seeing the industry move back toward rigor, and I think that is a very healthy thing.
Well said. I think we are going to see a lot of these ghost companies, the ones we talked about in episode 1113, struggle because they built their entire infrastructure on these unstable agentic foundations. They built houses on sand, and the tide of production reality is coming in. The cost of bureaucracy in an AI system is just as real as it is in a human one.
It is the agentic mesh problem. Too many agents talking to each other and not enough work getting done. But I think we have given people a good roadmap for how to avoid that trap. Focus on variance, watch your tokens, and keep the steering wheel in your hands whenever possible.
I hope so. It is a fascinating time to be building, but we have to bring some of that old school engineering rigor back into the AI space. Let the models do the talking, but let the code do the walking.
Well, that is all the time we have for this deep dive into the architectural critique of agents. This has been a fun one. Thanks as always to our producer, Hilbert Flumingtop, for keeping the show running smoothly and making sure our own internal loops don't get stuck.
And a big thanks to Modal for providing the GPU credits that power this show. They make the technical side of what we do possible, and they do it without any unnecessary agentic overhead.
This has been My Weird Prompts. If you're enjoying the show, consider leaving us a review on your favorite podcast app. It really helps us reach new listeners who are trying to navigate this wild AI landscape and avoid the agentic tax.
You can also find us on Telegram by searching for My Weird Prompts to get notified when new episodes drop and to join the conversation about the future of engineering.
We will see you in the next one.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes to facts on cue. We change and follow through. My weird prompts.